All right, so one of the negative effects of acid rain on soil is something called leaching. Leaching is when you lose important chemicals or nutrients for plants and other microorganisms that are in the soil. So these things are taken out of the soil by acid rain. And here's how this works. Normally in the soil, you're going to have clay particles, okay? And these clay particles have a negative charge. So we got a couple clay particles. They have a negative charge. Now, since they have a negative charge, they actually will attract positively charged ions. So in the soil, again, this is part of the soil. We'll have things like potassium ions, which is K+. And we have the positive and the negative of these two particles that will attract each other, just like magnets, right? Opposites attract. So the potassium is kind of held in the soil by these clays. And there might be some more potassium on this one, but we're going to find some other things too. Besides potassium, there might be calcium, Ca+2. So it also has a positive charge, and that positive charge is going to cause it to stick to the negatively charged clay, keeping that calcium in the clays, or in the soil, attached to the clays. And there's some other ones. There is magnesium. That could also be stuck onto here. And plants then will use the calcium and potassium and magnesium when it's time for them to take those up through their roots. Okay, so we talked about this idea of leaching, but we haven't really explained it yet. And we've got our clay with some of the minerals that are attached to these clays because of opposite charges. And when you get your acid rain, H2SO4, the acid rain is going to have H2SO4 mixed in with the water molecules. And that rains. And as part of this, we haven't really talked about acid-base solutions yet. But what happens is this H2SO4 is going to break apart into hydrogen ions and sulfate, this SO4, which is a 2 negative. And it's really these hydrogen ions that are going to be our problem. Because what they'll do is they're going to interfere in the bonding of the clay and the other nutrients. So they come down, attach themselves to the clay, and what ends up happening is that there's less of an ability for these other things, like calcium, to stay attached. And they will run off, just like this potassium over here, we got the calcium there. They will run off with water. So as water washes through the soil, these nutrients get leached out of the soil. They get eroded away, they get washed away. And all of these hydrogen ions from the acid rain are what are now clinging to those clays. And those don't do plants any good. So when the plants need to get calcium or when they need to get potassium, it's no longer there in the soil. It's no longer attached to the clays. It's been washed away by water because it can't bind the clays anymore because it's having to fight for a position with the hydrogen ions. Okay, I think that gives us a little bit of an idea of soil. Let's go and talk about some of the plants. All right, so the next thing I want to talk about was acid rain affecting trees and plants directly. So we're talking about leaves and needles. And if you look at this image, what you can see is there's two branches here. The one on the left does not look as healthy as the one on the right. And the one on the left has been affected by acid rain. Now the acid rain doesn't directly start to kill the leaves and needles. What happens is, just like last time, when we had the hydrogen ions, that H plus, come in from the acid rain, it again causes the other nutrients to get stripped away. So over on the right, we've got a healthy branch with healthy needles that has a healthy amount of nutrients in the leaves, like potassium over here on the right, that K plus. That acid rain has those hydrogen ions that come off of the sulfuric acid, and they bind in those places where the potassium would be binding. So the potassium gets washed away or stripped away. When the leaves and needles start to deteriorate, so they lose their outer protective waxy layer, you'll notice on leaves a lot of times they're smooth. They have a waxy layer on them that protects them from disease and pests, insects, things like that. Um, Once those leaves start to deteriorate, they can't go through photosynthesis as well. They can't protect themselves as well because they don't have the waxy outer layer anymore. Um, and they're more susceptible to pests and disease. And you can see an image of this forest here that the trees are all dead or dying. And it's not because the acid rain like burned them alive, but it's because it weakened them to a point where they could no longer grow and thrive. So that's what we see in forests that are affected by acid rain.